Hello everyone, I'm Zhida from the Hong Kong University of Science and Technology. Today I'm going to present our research on supporting gesture-based interaction design with metaphorical meanings. This work was done with Sitong Wang, Chengzhong Liu, and my supervisor Xiaojuan. To give a background, an emerging trend of recent human-computer interaction research and practice showcases gratifying experiential designs with daily interactions. The social swipe example here demonstrates a credit card-enabled campaign, which could create unexpected and enjoyable returns to the donators. Such an interaction shows an abstract meaning of help or freedom and lets the users know how their donation will benefit those who are in need. Similar interactive content can also be transferred into mobile and wearable devices, which support even more daily interactions. Existing examples have turned mobile devices into musical instruments by familiarizing users with everyday gestures instead of applying conventional mobile interactions. However, how to systematically design gesture-based interactions augmented with a meaningful experience, especially on mobile and wearable devices, is still under investigation. This work aims to help designers systematically explore and formulate design ideas that express abstract meanings through gesture-based interactions. To achieve this goal, we propose Metaphoraction, a creative support tool that generates design idea candidates based on designers' input. We first decode an idea which connects an interactive gesture to an abstract meaning into 4 components, that is, gesture, action, object, and meaning. We further decompose the main research question into 4 sub-questions, and I will go over them in detail. The first question aims to explore common mobile and wearable gestures. To solve this question, we conducted a literature survey on common mobile and wearable interactions, while focusing on the ones supported by daily mobile and wearable sensors. Following the adapted Prisma statement, we finally got 71 papers for further analysis, which were collected from the top 20 HCI journals and conferences. Please refer to our paper for more details about the selection and screening process. After obtaining those papers, we coded the presented gestures, which are user-friendly, feasible for implementation, and commonly used across mobile and wearable devices. Excluding the culture-related and symbol-like ones, we finally have 52 distinct gestures. We further categorized those gestures into device-based, touch-based, and vision-based interactive gestures according to their action space and applied objects when acting. We found that the most involved body part is single hand, which is not surprising, as it applies the most convenient and flexible gestures. We also coded the related sensor categorization information for future research. The second question identifies the corresponding actions and associated objects when mapping the gestures to the physical world. We target RQ2 by collecting general users' interpretations of common interactive gestures performed in daily settings after receiving those 52 gestures. The study aims at understanding how people map digital interactive gestures onto physical world actions and the immediately associated objects. To achieve this goal, we designed a crowdsourcing task to collect the possible actions, target objects, and underlying intentions from general users. Then we recorded demonstration animations for each interactive gesture, posted the study online, and recruited participants through Amazon Mechanical Turk. Each task contains 3 gestures, and for each gesture, participants are encouraged to provide as many cases as they can. In the end, we had 4,036 valid answers in our collected data. We then cleaned the data by extracting pure verbs and nouns from the answers, and we got 485 unique actions and 721 unique objects. Those actions can be further grouped into communicative and manipulative ones. The distribution of collected actions here shows that manipulative gestures accounted for most participants' answers, reaching around 71%. In the rest of the communicative gestures, speech-independent and speech-related gestures accounted for about 21% and 8%, respectively. The third question investigates the widely accepted meanings extending from the objects based on metaphor pairs in the semantic space. At the very beginning, we would love to mention that we consider language as a proxy to study metaphor by referring to previous research. To tackle the third question, we want to find meaningful metaphors first. So we started by obtaining a large metaphor dataset containing more than 900,000 unique metaphor pairs with pair frequencies. Then we conducted another MTech study to understand how people interpret the meaningfulness of a particular metaphor pair. To measure metaphor meaningfulness, we asked each participant to rate 50 target source pairs along a 0 to 3 scale. At the same time, we also implemented a model using GBM to calculate meaningfulness probabilities for the unlabeled data. We found that the model's performance would unlikely to get improved after the sample size reached around 4,200. Therefore, we ended the study with 4,260 valid metaphor pairs. To understand what features make a metaphor more meaningful, we ran a feature importance analysis and found that concreteness ratings of the source played an important role. For now, we have obtained all the information that we need to build our prototype Metaphoraction. With all the data collected from previous studies, we implemented a web application for further evaluation. The interface of Metaphoraction includes a searching box, a SIGCHI diagram to present the possible design idea candidates, a control panel and node operation panel to adjust the diagram, and a description view to obtain all the detailed meta information of a particular node in the SIGCHI diagram. Lastly, we conducted semi-structured interviews to openly explore design experts' feedback on the tool and the ideation experiences. We held a design workshop with a professional design team from a local company. We proposed 4 tasks in our workshop considering various scenarios, including discovering possible design idea candidates, finding the optimal candidate, extending ideas from existing designs, and validating design rationale. Here are some sketches drafted by the participants. This video demonstrates how to get an idea from a designer's raw input with Metaphoraction. The user typed in happiness and got feedback from the system. Then he browsed the possible objects related to that meaning. He chose gift. Next, he searched gift for more achievable results. He chose the action of show, and after filtering with the meaning of happiness, he browsed the details of the left gestures for possible designs. He finally chose display as a result. From this work, we reflect on the commonalities in designing meaningful interactions. It is recommended that a design should first be functional and reliable, then become accessible and convenient, and eventually create pleasurable experiences with meaning and value. As a practice, interaction design strives to create more meaningful relationships between users and the products and services that they use. Promising application domains include educational material design for kids, game design, and advertisement design. Designers should consider the cultural and social factors, available devices and scenarios, and target users' best practices when designing interactions with meanings. To summarize, we propose a solution to facilitate the systematic ideation for gesture-based interaction design with metaphorical meanings. At the same time, we build a tool, Metaphoraction, to evaluate our ideas. Experts from our design workshop suggest that Metaphoraction can support the ideation of meaningful gesture-based interactions with improved productivity and creativity, which we highlight in our paper. Thank you for listening. Please check out the full paper for more information. If you would like to know more about this research, please also feel free to get in touch.